Greetings, salutations, all those nice things. Welcome to our fourth topic, which is radical functions. Now, we've looked at radical functions a bit before in our first topic, where we first started talking about transformations at all. We're going to look at radical functions and transformations again. We're going to look at the radical function as a transformation a bit later, and we'll also be looking at how to use the graphs of radical functions to solve radical equations. So all in all, pretty interesting. Now we've got our parent function here. This is the graph of y equals the square root of x, where of course this thing is labeled properly, and that's y, and that's x. There's a 1. There's a 1. Right? So we've got some key points like 1, 1. We've also got 4, 2. We've got things like 9, 3. But also very important is this key point right here at 0, 0. That's where this whole function originates. And then it goes on forever and ever because you can take the square root of any positive number. So why not go all the way to infinity? It absolutely must terminate at 0 because we can't take the square root of anything negative. Non-negative, cool. Negative, bad. Now when we look at this in terms of transformations, we take this function and ask, what is the function actually doing? Right? Like when we process in this form, what does this say to do to x? Well, it says to take your input, whatever your input is, and stick it under the square root. So knowing that is what helps us determine what is actually a horizontal effect and what's actually a vertical effect. In that if it's in this function's brackets, then it must be part of the radicand for this function. So that's that dealio. Away with these. So we'll graph these. We will graph these radical functions. We can do them straight up through transformations if we want. If you want to use a table of values, go for it. If you want to take this in stages and do one transformation at a time, that's absolutely acceptable. But choose your own adventure. Of course, no matter what you do, make sure you label your scale and you label your axes. As usual, I'll start with just the axes first, label the scale once I'm done everything. Noting this negative 3 says that we're going to move the function 3 to the right because it's inside the square root, it's part of the radicand, therefore it's a horizontal effect. So we're going to move 3 to the right, and this negative 2 tells us we're moving 2 down. It's not part of the radicand, it is a vertical effect. So the point normally 0, 0 would go 3 right and 2 down. The point 1, 1 would go 3 to the right and 2 down. The point 4, 2 would go 3 to the right and 2 down. And we can do this for any point that exists on the original function. So 3 to the right and 2 down is there. 1, 1 becomes 4, negative 1. 4, 2 becomes 7, 0, 4, 5, 6, 7, 0. And then we play connect the dots. Now this should still resemble a radical function, so it has that gentle curve to it. There's no jaggedness to this drawing at all. Don't mind labeling my scale now. And of course we should see the original function in that transformed one, right? Like if we take this thing, we should be able to just shift it 3 right, 2 down, and get the exact same thing back. So that's necessary. This one is done. If you want, you can try this next one. Why not? Ooh, it's got a lot more involved. Ooh, including a trick. If you paused the video, cool. If you didn't pause the video, pause it now to see what you can do. Now we're used to seeing things in the form of, how you say, f of b x minus h. Except that's not what this is. We've got something minus x. So we've seen that trick before. Let's just make sure we factor that out. So it's like negative of x minus 1 inside the radical. Oakley dokes. If x we're going to see, we will have a vertical reflection about the x-axis, of course. We're going to have a horizontal reflection about the y-axis. And then we're also going to be shifting 1 to the right and 3 up. Normally, we're always saying do your stretches, compressions, reflections first, and then do your shifts. And technically that's still true. But if you're wondering where points go, note that as we map the point 0, 0, it doesn't get affected by any stretches or compressions, and it doesn't get affected by any reflections. This is because when you multiply 0 by anything, you still get 0. So even if this thing had like a 2 in front here, well, 2 times that 0 would still be 0. So if you're wondering where 0, 0 goes, really you can just look at the shifts. So these translations tell us that 0, 0 is going to go to be 1, 3. There it is. For any other point, you will have to take into account what happens in terms of stretches, compressions, reflections. Right? So the point 1, 1, a horizontal reflection would make this negative 1, but then we're going 1 to the right. So that's 0. And then this one times negative 1 because of that, because of the vertical reflection makes it negative 1. But then 3 up means we're actually at 2. And a point like 2, 4, try to map it yourself, but let's see where it goes. Horizontally, so 2 becomes negative 2, but then we shift 1 right, so negative 1. And for the point, for the y value of 4, times negative 1, because of the vertical reflection, is negative 4. 3 up means we're at, wait, what? Oh yeah, negative 1. Oh, whoops, that's what I did wrong. It should be 4, 2, Captain Genius. There we go. All right, let's figure this out again. So this thing times negative 1 and then plus 1 is that. This thing times negative 1 plus 3 is that. Whew, that makes a lot more sense. The thing I noticed was just that if I had gone with a 2, 4 and said it turns into whatever we had this going as, horizontally negative 2, so that was negative 1, and saying that it went to 4 times negative 1 plus 3, saying that it went to that, like, yeah, I'd have the 0, 2 point here, that's all good, but then this next point being here, I would notice, like, that doesn't make things radical, right? We'd be doing this at some point, that just doesn't work. So that's kind of what I noticed, that's how I noticed I was making a mistake. Anyways, that mistake is out of our minds now. Negative 3, 1 is right there. If we wanted to continue the pattern, we could. That's up to you. 1, 2, 3, 4, 5. This would probably be there if I were a guessing man. And then, of course, we play connect the dots. forget to label my axes. That one's done. So we can also determine the equation of a radical function from its graph. Now earlier I mentioned that the point 0, 0 doesn't get affected by any stretches or compressions or reflections, and that basis point, that starting point for any radical function, can immediately tell us what we've got in terms of shifts. So the fact that this point is at 1, -2 immediately tells us that we went to the right by 1 unit and that we went down 2 units. That's how far off we are from the origin. Then we need some other point to tell us what we did. Now normally from here, we would just go there, right? No stretches or compressions, that's what we do. We take a look at our original parent function. From 0, 0, the next point is 1 over 1 up. That's where it's supposed to be. This thing is 1 over 2 up. Therefore, we must have a vertical stretch factor of 2. Altogether for this function then, y equals 2 times the root of x minus 1 to make us go right 1 unit, minus 2 to go down 2 units. Quick, try the other one, there's no time, I dare you. Hopefully you paused. I'm continuing. This point is at 1, 2, 3, 4, 5, 6, 7, 8. So we went 8 units right, and 1 unit up. I can tell there's been a horizontal reflection. Because normally this thing would open that way, but now it's opening the other way. So it must have been reflected horizontally. Not vertically. Vertically means this thing's going down, down, down. And it's not doing that. So a horizontal reflection. Any kind of stretch or compression. Well, here's that point that would have been 0, 0. Normally we would go over 1, up 1. But there's been a horizontal reflection, so our over 1 must be the other way. Over 1, up 1, checks out. So there's no other stretch or compression factor. And this one is just straight up y equals the root of negative x minus 8 plus 1. That's it for transformations. Hopefully it was a bit familiar to you, but there is some practice work for you to try out. So on those pages, give it a go, give it a whirl, give it a spin, give it a try, see what happens. And as always, let me know if you have any questions, comments, concerns via Teams chat or just ask me in class. I will miss you all till I see you again. I hope this lesson was the most radical